This is a programming example for data comparison. Two groups of students at a local university are enrolled in special courses during the summer semester. At the end of the semester, both groups are given the same tests for the same courses. Their scores are recorded in separate files. You will develop a program that reads the course scores for each group, calculates the average course score for each course for each group, and outputs the averages of the course scores. The course scores for each group are recorded in separate files. Suppose the data is stored in the file group1.txt for group 1 and the file group2.txt for group 2. A sample input looks like this. You can now process and output the data for groups 1 and 2. To find the average, sum the scores for each course. Count the number of students in each course, and divide the total score by the number of students in each course. Output the average course score for groups 1 and 2. A sample output looks like this. Processing the data for each course is similar and is a two-step process. First, you must calculate the averages for each course. Then you must output the averages. To simplify the complexity of the main function, we will write a function, calculateAverage, to find the course average, and another function, printResult, to output the data in the form given. By passing the appropriate parameters, we can use the same functions, calculateAverage and printResult, to process each course's data for both groups. In the second part of the program, we will modify the function printResult. Now that the problem has been analyzed, we can describe the algorithm. First, initialize the variables. Then, get the course IDs for groups 1 and 2. If the course IDs are different, print an error message and exit the program. Next, calculate the course averages for groups 1 and 2 and print the results. Repeat steps 2 through 5 for each course. You will then print the final results. Here is a flowchart giving a diagrammatic representation of the steps just discussed in the algorithm. The arrows in the flowchart depict the sequence or order in which the tasks are to be performed in the program. You will need to declare the following variables. Course ID 1 and course ID 2 are the two string variables to store the course IDs for groups 1 and 2. Number of courses is an int variable to store the number of courses. Average 1 and average 2 are the variables of type double to record the course scores for groups 1 and 2. Similarly, average group 1 and average group 2 are the double variables to store the average scores for groups 1 and 2. You will also need file stream variables to read data for groups 1 and 2. Group 1 and Group 2 are IF stream variables. An out file is an OF stream variable. Functions enable you to divide a program into manageable tasks. You can also use functions to complete the same task multiple times in a program. Because you will calculate the averages and print the results for both Group 1 and Group 2, you should create separate functions. As described earlier, we write two functions, calculateAverage and printResult. Let's take a closer look at the definitions of these functions before defining the main function. The calculateAverage function will compute the average for a course. Because the input is stored in a file, and the input file will be opened in the main function, you must pass the IF stream variable associated with the input file. After you calculate the course average, you'll need to pass the course average back to main. These parameters are passed by reference. You'll also need to declare local variables in the calculateAverage function. You need a variable to store the sum of the scores, a variable to hold the number of students, and a variable to store a score. You can initialize total score and number of students to 0. Use a while loop to update the total score. Increment the number of students by 1. and get the next course score until there are no course scores left in the file. Finally, to find the course average, you must divide the total score by the number of students. Now let us consider the function definition for print result. Pass 4 parameters to this function: the OF stream variable associated with the output file, the group number, the course ID, and the course average for the group. Like the IF stream variable, the OF stream variable is passed by reference. However, the remaining parameters can be passed by value. The print result function prints the course ID, group number, and course average. Now that we have designed and defined the functions calculate average and print result, we can describe the complete program listing. Include the header files to output data, to output floating point numbers with 2 decimal places in a fixed decimal format with trailing zeros, and to read from and write data to files. To help the compiler correctly translate each function call, type in function prototypes for calculate average and print result. Begin the main function by declaring your variables. Then open the input files group1.txt and group2.txt. If you are unable to open one or both of the input files, the program will print an error message and terminate. Next, open the output file student.out. Initialize the course average for Group 1, Group 2, and the number of courses to 0. Then, output the course number, group number, and course average. Next, get the course IDs for Groups 1 and 2. While there is more data to be processed in each file, if the course IDs for Groups 1 and 2 do not match, the program displays an error message and terminates. Otherwise, the programs calculate the course average for Groups 1 and 2 by calling the function calculateAverage and passing the appropriate parameters. Next, call the function printResult to print the results for Groups 1 and 2, pass the appropriate parameters. Update the average for Groups 1 and 2, and increment the number of courses. Then, get the course IDs for Groups 1 and 2. If not end of file on Group 1 and end of file on Group 2, print ran out of data for Group 2 before Group 1. Otherwise, if end of file on Group 1 and not end of file on Group 2, print ran out of data for Group 1 before Group 2. If neither of these cases is true, then print the average scores of Groups 1 and 2. With this, close the input and output files, and end the body of the main function. After the body of the main function is complete, you must now place the function definitions of calculateAverage and printResult as discussed earlier. These are the input files for the program. And a sample run of the program looks like this. You can modify the function printResult, which was defined in the first part of the program to display the course averages as bar graphs. Using the same input, reading course scores from group1.txt and group2.txt. You can output the course averages visually in the form of bar graphs. To do this, you can modify the existing printResult function to display the results using symbols to represent the average course scores in the form of bars, add a print heading function to display the heading, and modify the main function to call these functions. Our modified printResult function will use symbols to represent the course averages. But the parameters of this function will remain the same: the OF stream variable associated with the output file, the course ID, the group number, and the course average. To calculate the number of symbols used in the bar graph, divide course average by 2. Each symbol in the bar graph will represent 2 points. To print the bar graph, use a loop to print symbols representing Groups 1 and 2's average course scores. Group 1 will be represented by the star, and Group 2 will be represented by the pound sign. If a course average is less than 2, no symbol is printed. To display the first 2 lines of outputs, include a new function printheading. Modify the main function to include the function printheading. You can rerun the program to see how your redefined functions change the output to display the data in the form of a bar graph.